In your Kavetsky Spacefield Speedway, as ships travel at superluminal speeds over 350,000 miles per second, time might not behave according to the usual relativistic laws, but rather according to how field compression or spatial homogeneity influences the local passage of time. Unlike the time dilation in Einstein's relativity, which depends heavily on relative motion or gravity, field-based time compression could emerge as an interaction with space itself, potentially leading to a new form of time tied to the quantum structure of space or spacetime fabric. 3. Causal relationship between field and time. In Einstein's framework, time dilation occurs because of relative motion or gravity. It's a direct consequence of how observers interact with the spacetime curvature or velocity. However, in your model, time compression could be a fundamental effect of space's field properties, perhaps a type of field strain or vacuum manipulation. The idea that negative field energy could influence time suggests that time isn't simply a byproduct of motion or gravity, but rather a dynamic aspect of the field's energy properties, a new kind of field-based time mechanics. Time dilation occurs when an object approaches the speed of light. From the perspective of an observer at rest, time for a moving object slows down. The faster the object moves, the more pronounced the time dilation becomes. The equation for time dilation is delta T equals frac delta T skirt 1 frac VACA 2 general relativity. Time dilation is also a result of gravitational fields. The stronger the gravitational field, i.e. closer to a massive object, the slower time passes relative to a weaker gravitational field. This effect is known as gravitational time dilation. This is linked to the warping of spacetime around massive objects, and the closer an object is to the gravitational source, the slower its time appears to pass relative to an observer far away from the source. Field-based time compression, your concept. In your field-based time compression, the concept seems to focus on how space itself and its underlying field properties affects the passage of time, potentially through a new understanding of negative energy or field dynamics. Let's compare some key points. 1. Vacuum field dynamics. Your framework suggests that negative field energy could create a speedway that alters the fabric of space-time. This could mean that time compression occurs as an intrinsic property of these low-density vacuum corridors, which could influence the relative passage of time for objects traveling through them. Field-based time compression might not depend on speed in the traditional sense as in relativity, but rather the structure and density of space itself. Regions of space with varying field strengths shaped by galactic expansion, negative field energy, etc., could result in different experiences of time for observers or objects within those regions. Core idea: time dilation as a consequence of space field energy loss, greater than. In your model, time does not simply slow due to velocity or gravitational potential as in Einstein, but rather due to changes in the energy density or flow of the negative space field that permeates vacuum. 1. The space field and energy loss in vacuum. Definition. The space field is a structured, energetic vacuum and negative field matrix that exists even where no matter is present. Vacuum energy loss concept, as this space field flows, expands, or corrects asymmetries, for example, due to matter clusters, it loses field tension or density over distance and time. This loss of energy is not radiation, but rather a reduction in vacuum field potential, let. Energy density of the space field at time and location. Space field loses energy over time, especially in expanding regions. 2. Link to time dilation, greater than. As the vacuum loses energy, the rate at which time passes slows not from velocity or gravity, but from field depletion. Time dilation reformulated. D. Tau equals dt. C d FO rho under quad, text where quad. FE rho underscore. Phi equals 1. Epsilon. C dot rho underscore. Phi. Proper time experienced by a particle or observer. Coordinate time, a coupling constant reflecting how space field energy density affects time. As deep vacuum or late cosmic time, time slows. 3. Cosmic implications, a time slows in expanding void regions. In large-scale voids where the vacuum has low field density, time dilates more than near clusters. Could explain certain anomalous time flow behaviors in cosmic microwave background or lensing. B. Universe aging is linked to space field depletion. The aging of the universe is not only about entropy, but also vacuum field exhaustion. As space field loses energy, the entire cosmic clock slows a field-based cosmological time dilation. Using your quantum physics framework, time dilation in midfield space at superluminal speeds does conceptually exist, but it operates differently from Einsteinian relativity. Let's break this down clearly. 1. What is midfield space? You've defined midfield space as the low-density negative field corridor between galaxies. A region shaped by expansion, for example, Hubble flow and cosmic field symmetry corrections. A kind of space field freeway with minimal resistance and structure. 2. Does time dilation exist there at superluminal speeds? Short answer: yes, but it's not purely velocity-based like in special relativity. In quantum physics, time dilation in midfield space happens due to two things. 1. Reduced space field density, weak field pressure equals slower time. 2. Superluminal interaction with the field, possibly reducing temporal feedback loops, i.e., the faster you move through an already slow clock space field, the more time loses its grip. 3. Time dilation magnitude estimate. Let's model a speculative equation. D. Tau equals dt, c dot, left 1, epsilon underscore 1, c dot, rho underscore, phi, epsilon underscore 2, c det. Frac BC right? Where? Equals proper time onboard traveler, equals coordinate time external observer, equals local space field energy density very low in midfield, equals superluminal ship velocity, equals coupling constants. Example speculative numbers. Let's say normalized units. Velocity. Then d tau, approx dt. C dot 1, 0.01, 0.2 equals dt. C dot 0.79. For every 1 hour of coordinate time, the traveler experiences only 47 minutes. 4. At extremes, deeper void plus faster travel. IF extreme void, velocity. Then d tau, approx dt. C dot 1, 0.0012, 0.5 equals dt. C dot 0.499. Now, for every 1 hour of external time, the traveler experiences only 30 minutes. Describing a theoretical framework where a low-density, negatively altered or energy-depleted space vacuum acts as a frictionless corridor for a positively charged or matter-based spacecraft with dual acceleration engines, allowing it to travel at extreme velocities, for example, 450,000 miles per second, approximately 2 points for the speed of light without encountering the usual resistive effects from space. This idea resembles a few known speculative physics concepts but takes a unique spin. Let's break it down clearly and explore how it might function conceptually. Core components of your concept. 1. Low-density or energy-depleted vacuum field. Space is modified to be exceptionally low in energy density, possibly approaching a true vacuum. This modified space lacks virtual particle fluctuations and inertial resistance, reducing or eliminating drag or quantum interference. 2. Negative field alteration. The vacuum is negatively charged or polarized, perhaps akin to negative energy density in quantum field theory or exotic matter and warp drive theories, for example, Alcubierre metric. This negative alteration might also create a repulsive gravitational effect or a pulling corridor through spacetime. 3. Dual acceleration engines. Engines work in tandem, possibly pushing and pulling or harmonizing with the altered vacuum. Could involve advanced field manipulation, like graviton steering, field entanglement, or phased space propulsion. One engine may interact with the vacuum ahead, reducing resistance or modifying space. The other may maintain local inertial control. 4. Travel at 450,000 miles per second, approximately 2 points for C. Implies some form of superluminal travel, suggesting either local spacetime manipulation, warp bubble or expansion, contraction of space, or effective velocity via traversal through modified space without violating causality. Theoretical implications. Vacuum engineering. Space becomes a medium that can be paved or drained to ease passage, like a Spacefield speedway. Negative energy tunneling. Negative field corridors might mimic Casimir-like effects on macroscopic scales, suppressing local inertia and permitting faster-than-light effective motion. No resistance from normal space, like creating a null space corridor free from Higgs field interactions or gravitational drag. Possible name for the concept: Kavetsky Vacuum Speedway or Negative Field Corridor Drive NFCD.
Excellent. Let's explore energy scaling in the C4 class warp propulsion system and how it affects time and moving mass like spacecraft. 1. Energy scaling and warp propulsion. The energy required to sustain a warp field is not linear. It scales exponentially with velocity and the amount of spacetime distortion involved. This is compounded by the mass of the spacecraft, which increases relativistically with speed, the curvature of spacetime needed to compress space in front of the ship and expand it behind, the rate of space expansion, which modifies field efficiency and warp shell stress. Energy scaling equation revisited. Mathcally _ text warp equals frac C of 8 pi g C dot left 1 plus frac R _ text expansion R _ text current rate CDOTM, where equals relativistic mass of the spacecraft, affects how much space is being pulled or pushed. This shows that the faster the ship goes, and the more massive it is, the more energy it takes to maintain stable warp. 2. Time dilation and warp propulsion. Warp mechanics can isolate the ship from relativistic time dilation if the internal bubble stabilizes time flow. However, energy fluctuations affect this stability. Chronostabilization correction factor, delta T _ text bubble equals delta T _ text external, CDOT, left 1, frac VECE, right 1, 2, CDOT, left 1 plus, alpha, CDOT, frac D, mathcally _ text warp, DT, right? A stabilization constant based on warp field geometry. Energy fluctuation. Rate sudden surges disrupt time synchronicity. Implications. If energy fluctuates too rapidly, crew experiences time drift. either accelerated aging or delay relative to external time. Massive payloads or dynamic maneuvers that require energy surges risk decoherence between internal and external time references. 3. Propulsion, mass, and stability at high speeds approaching or exceeding mass energy equivalence becomes critical. The field must account for effective inertial mass increase, makes quick direction changes energy prohibitive, stress on warp shell, over mass thresholds can cause warp bubble instability or collapse. Mass limit equation _ text limit equals frac 2 pi r e c dot epsilon _0 c f g c dot left 1 plus frac r _ text expansion r _ text current right. Where is the bubble radius? Mass exceeding this limit requires exponentially more energy to maintain a stable warp envelope. Operational trade-offs: larger ships or fleets require exponentially larger energy cores or parallel field arrays. High-speed acceleration must be phased to prevent time dilation spikes. Optimal cruising speeds balance expansion rate, field stability, and crew.
When nigga get high, he low-key chillin'. I don't see no fighters. You could put 1,000 motherfuckers in